Right, let's have a look at locked cages by Chili. Normal Sudoku rules apply. Normal lockout line rules apply. So let's just get rid of that and look at this. So these are going to be our lockout lines. Digits in diamonds directly connected by a lockout line must differ by 4 or more. Okay, so these two diamonds are connected directly by a lockout line. I assume this and this diamond are not directly connected, right? This directly connects to these three. But none of those three directly connect to each other. Now, whatever digits we put in these diamonds, the difference must be at least 4. So for example, we could put 1 and 5, or 2 and 6, or 3 and 7, etc. Digits on a line must fall outside the range defined by their diamonds and may repeat if allowed by other rules. Okay, so that's the lockout. So that makes sense. So this is a new rule. So I'm just kind of thinking about it a little bit. New rule for me at least. So actually, if I look at this one, this is a length. How would you say it? A length 4, or maybe you would say a length 6 lockout line. So these two must differ by exactly 4. But anyway, let's first finish reading the rules. The clues in the upper left corner of the cages give the sum of the digits in the corresponding cages. Digits in a cage may not repeat. Okay, so just normal killer Sudoku rules. So let's reset our timer and let's think about this. So I'm looking at this lockout line. These have to differ by exactly 4. Right, because then we're going to have consumed 5 digits. And then we will only have 4 digits remaining. If they differ by any more than 4, we won't have enough digits to put here, since every digit on this line must be different for reasons which include both regular Sudoku and also the lockout rule, which states, to be precise, that the numbers within here cannot be equal to these ones and must fall outside the range of those. But now we don't. Well, so we don't know what these are, but we just know that the difference is going to be exactly 4, because it could be 3 and 7, and then we will have 1, 2, 8, and 9 to put here. But well, I definitely can't put 8 or 9 in this one. Yeah, what's not going to be possible is for this to be 1 and 5. Because then this would have to be at minimum 6. So we need this to be at maximum 5. So we need to start at least at 2. So we can't have a 1 in the diamonds, because we can't exclude 1. Well, you could exclude 1, but it's just the range is going to be 4, so that's the issue. So this must be at least 2, 6, but it could also be higher. This 15 cage is going to give us 1, 2, 3, 4, 5 to make 15. And just to go through this again, the possibilities are going to be 4 and 2 and 5 and 1. Right, but you're never going to be able to have 5 on this lockout line, right? Because there's just no way to not include a 5 in the lockout line. So that's not going to be 5, and that's not going to be 1. There's no ways to not include 5 in the prohibited range of values, right? Because even if we look at the one extreme, which is 1, 5, 5 is excluded, and if we look at the other extreme, it's 5, 9. So because 5 is kind of in the middle there. Okay, 6 from 3 is going to be 1, 2, and 3. This cannot be 1 though. 24 from 3, gosh. Does that have to be 7, 8, 9? It does, yeah. No, yeah, it does. That does have to be 7, 8, 9. So this can't be 9. It's either 2, 7 or 3, 8. So that helps us. Now, what else do we have here? We've got another 1, 2, 3, 4, 5. And 23 now introduces some degree of variability over there, where we can't be 100% positive what that's going to be. This is either 6, 9 or 7, 8. Whoops, 6, 9 or 7, 8. Then 23 probably has to include a 9 or something, but I'm not totally sure. We'll come back to that. I don't think that's super important right now. So let's look at this one, because this is also a length 6 lockout line. So this has to be 1, 5. Let's keep going. What can we say? So let's look at this one. This is a length 5. So 3 would have to be 1, 5. Okay, cool. Well, there we get some digits. That's not 1, that's 2, 3. That's none of these are 5. That's going to be 1, 5. So these are going to be taken from 6, 7, 8, and 9. These are going to be 6, 7, 8, and 9 exactly. Five. This could be a 1 or a 9. This becomes a 1. I'm a bit slow because I'm still kind of getting used to. This rule. This one we don't know. Could be 5, 6, 7, 8, or 9. I'm not going to pencil mark. That's too many digits. This is from 6, 7, 8, 9. But can this be a 6? Yes, it can. Because you can have 9, 8, 6, 15, 23. Yeah. That can be a 6. But this is also from 6, 7, 8, and 9. So actually we have a quadruple there. 6, 7, 8, 9 quadruple. But we can't fill these in because there's too much ambiguity in these cells. But we all know it's going to be from 2, 3, 4, and 5. That one's not from 5. Well, that one can't be 5, let me say. Come on. What else can we say? Oh, this can't be 5 and 1. That'll have to be a 9. Because if that were 5 and 1, then we would be selecting from 6, 7, 8, and 9. But then we're trying to spread 4 digits over 6 cells, which is obviously a problem. So that is going to be the 9, which means none of those are going to be the 9. So 9 here, 9 here. One of these are a 9. Don't know where. One of those are a 9. It's not very helpful. Let's look at this a little bit. So 2, 7, we make that a 1. 3, 8, that could be a 1 or a 2. but in neither case is it a 4. And then these digits are going to be from 8, 9, 1, and 2. Is that correct? Wait, if it's 2, 7, yeah, you have the 1 and you have the 8 and the 9. If it's 3, you have the 1, the 2, and the 9. Yeah, okay. That's almost, it's kind of interesting. It's almost kind of a penta or a sextuple rather, of 1, 2, 3, 8, 9. Wait, it is 1, 2, 3, 7, 8, 9. Huh. Okay. 4, 5, 6. Right? That just seemed like a sudden great leap of logic, but I trust my pencil marks, and we have 6 digits over 6 cells. 1, 2, 3, 7, 8, and 9. Okay, so that's going to be 4, 5, and 6. But this one can't be 4. It could be 5 or 6. But now we have definitely a 4 there. So that's not 4. So one of these is a 4, which means that's not 4 and that's not 4. That's 2, 3. We have a 2, 3 pair. 6, 7, 8, 9. 1, 2, 3. Wait a second. Where does 4 go in column 4? Well, according to our pencil marks, it can't go anywhere except here. And if that's a 4, it's either an 8 or a 9. I was going to say it has to be a 9, but that's not true. That's a 1 or a 2, which gives us a 1, 2 pair in row 3. And this is going to be from 1, 2, 3, and 9. Gosh, the pencil marks are getting a bit out of hand, and I feel like I'm probably missing. Yeah, you see. I mean, even here already, I don't trust. I don't trust that my pencil marks are very clean. Okay, here's another leap of logic. That can't be a 6, because then we run out of digits here. So that is going to be the 5. So 5 comes out from there. That's 4 and 6, so that's not a 6. That's not a 5. Two, 3, 4. 2, 3, 4, 5. Okay. Let's keep going. 5 and 9. Man, pencil marks are getting too much. 2, 3. Okay, so let's kind of see where we're at here. We still don't know what these are. I'm just going to go through all of our lockout lines. Well, that's still 8 or 9. 6, 7, 8, 9. So 8, 9 comes out of there, and that's a 1, 2. So that's 8, 9. That's 1, 2. That is 3. Whoops. Hold on a second. Hold on a second. What did I do there? Because something went wrong. I said we have a 6, 7, 8, 9 quadruple. So I took 8, 9 out from here. Right, that was the mistake I made. 3 and 7. So that's 8, 9. That's 2. Those are not 2. Let's stay focused. Let's try wrap this up. There we go. I knew something was going to pop out. There we go. Let's keep going. Let's keep going. Okay, not sure how long that was sitting there for. But we pick up the 4 in box 6. Mm-hmm. Can you have a 7 over here? Yeah, I'm sure you can, because you can do 7 at 15. Wait a second, 7? That doesn't work. 7, 9, 7, 9. That doesn't work. 7, 6, 8. That doesn't work. This is the 7. Can't have a 7 in that. Six, 8, 9. That's the 7. No 7 there. And we should be getting to a point where we can just do some Sudoku and run with it. 1, 2. What's happening over here? We're not looking at our killer cages enough. 7, 9, 7, 8, 7, 6, 3, 2, 4. What about this one? What am I doing here? So yeah, no, that's still correct. I wanted to. Okay, where should I focus my attention? 6, 8, 9, 1, 2, 3, 4, 1. This is thinking if that's 4, 9, then this has to be 1 and 3. And that's a 2. And that's seems fine. Well, one of those is definitely a 1. Actually, one of them actually is a 3. I've just realized. Because there's nowhere else to put 1 and 3. So that is 1 and 3. But that doesn't actually tell us what that is, but it does tell us what this is, which is a 2. Six, 7, 9, yeah, 7. What did I remove from here? Wait a second, sorry, I'm just going back. I took the 7 out earlier. Okay, I took the 7 out earlier and I forgot to remove the corresponding 8 from there. Yeah. 9, okay, probably we need to do some Sudoku. Probably we need to do a bit of Sudoku. So one's in one of those two positions. But one is here. You see, just need to do some Sudoku, that's all. Yeah, just doing some Sudoku. I know, it took me a second to realize. Hopefully we propagated those changes fully. One there. One's in one of these two positions. 1, 3, 1. Yeah, that's pretty much all we can say about our ones right now. We do have a 2 in one of those positions. We have a 2. Oh, that's a 1-2 pair actually. And that's probably going to be the best we can do with 2s. We can place the 3. We can place another 3. That's a 1-3 pair. We'll come back to that. 3. 1-3. 1-3, 6, 7, 8, 9, 2, 5, and 4. The 4-5 pair doesn't help us. Something creeping me out about those 3s, but I think it's fun. So 4 is one of those positions. 4, 4, 4. This is a 2-4 pair actually. 4, 4, 4, 4. 4, 4, 4. 4's over there. 5. That's going to be the 4-5. 4, 5, 8, 9, 1, 2, 3, 7. That's going to have to be a 6. 4, 5, 4, 5. We are going to have a 5 right here. Going to have a 5 there. 4, 5, and we're missing a 5 here. Let's pencil that in, why not? All right, let's try finish strong. That is going to be our 6 over there. That's going to be our 6 over there. That's going to be our 6. Let's fill those in. And let's try propagate that. 6s. That should be good enough. Let's go. We got 7s here. Got 7s here. This is not a 7. It's from 6, 7, 8, 9. Well, from 7, 8, 9 at least. 7 actually has to go there, which puts our 7 here, which takes the 7 out from those two, so 7 is in one of these. That is 7, which makes that 7. That's our 8, 9. That's going to be the 6. That's 8, 9. Oh, no, that is 8. That is 9. That is 8. That is 6. That is an 8, 9. That's 9. That's 8. That's 9. Those. Which one is 6? This one is 6. This one is 8. It's 8, 9. That's got to be 8, 9. That's got to be 9. Say that 8. That's that like that. Like this. 1, 3, 4, 5. Oh, there we go. 1, 3. 4, 5, 4, 5, 4, 5. Okay, 2, 4. That looks fine. So what are we missing here? 8 and took me a second. 8 and 7. And we can't disambiguate that yet. 2, 3, 4. But that will have to be the 2. Which makes that the 4, which makes that the 3. Let's see. Did I do that right? Just hang on a second. Hang on a second, because I don't want to mess this up right now. Yes, we're taking it from 2, 3, 4. That must be the 2. Yeah, okay. I'm happy with that. What are we taking from here? 1, 2, 3. Sorry, 1, 2, and 4. 1, 2, and 4. Oh, but there's no 2 there, so that's the 2. That's the 4. That's the 1. Let's finish strong. 7 and 8. 7 and 8. 7 and 8. 7, 8. And what's our third digit? 1, 2, 3. It's gonna be 6. Okay. Let's pretend like that never happened. And then over here it's gonna be 7, 8. Wait a second. What? I was wondering, how am I going to disambiguate this cross of 4 5s? And then I realized it's because there's a killer cage that I did not look at for a very long time. And our 7s and our 8s. What am I missing here? Oh goodness me. I really hope I did not make a mistake. Cool.